Hey everyone, today we're going to do something really cool. We're going to bridge that gap between the digital world and the physical world. We'll take a few simple lines of code and use them to literally bring a light to life with an Arduino. It's the classic hello world of electronics, and it is the perfect place to start. Have you ever wanted to take the code you write on your computer screen and make something actually happen in the real world? Well, that's exactly what we're about to do. This is where software gets to meet hardware, and it's awesome. Now, making a little LED blink might sound super simple, but trust me, it's a huge first step. This one project teaches you the two most important skills in this whole world: how to build a basic circuit and how to control it with code. These are the building blocks for, well, pretty much everything, from robots to your own smart home gadgets. And at the heart of it all is this little blue board, the Arduino Uno. The best way to think about it is as a tiny programmable computer. We're going to give it a list of instructions, and it's going to follow them to control our circuit. It is the brain of this whole operation. All right, let's get our hands dirty and actually build this thing. If you're totally new to this, don't worry. It might look a little complicated, but you're about to see it's really just connecting a few dots in the right order. Let's break it down. And here is our goal. This is what we're aiming for when we're done. You can see we've got the Arduino, a resistor, and an LED. That's it. This picture is basically our blueprint for the next couple of steps. Okay, let's walk through putting this together. First, grab your LED. You'll notice one leg is a little bit longer than the other, right? That long leg is the positive side, called the anode. Connect that leg to one end of your resistor. Now, why the resistor? Well, it acts like a gatekeeper for the electricity, making sure we don't send too much power to the LED and burn it out. Super important. Next, take the other end of that resistor and plug it into the digital pin that's labeled 13 on your Arduino. This is the special pin we're going to control with our code. And finally, that short leg of the LED, the cathode, that gets connected to the pin labeled GND, which stands for ground. This completes the circuit and gives the electricity a path to flow. And just like that, you've done it. Seriously, take a moment. You have successfully built your very first electronic circuit. The physical part is all done. That is a fantastic milestone. Now for part 2, the code. We've built the body, so now we need to give the brain its instructions. We're going to write a really simple script, or a sketch as it's called in the Arduino world, to tell pin 13 exactly what to do. Believe it or not, this is the entire script we need to bring our circuit to life. It might look a little bit cryptic at first glance, but I promise, every single line has a very specific and simple job. So let's break it down together so it all makes perfect sense. You know, every single Arduino sketch is built on 2 fundamental blocks: setup and loop. Just like the slide says, think of void setup as setting up a board game. You do it just one time at the very beginning. Then you have void loop, which is like playing the game itself. The instructions inside it just repeat over and over and over again, which is exactly what we want for something that needs to keep running. Inside our setup function, we have just one command: pinMode. This is our one-time instruction. We're basically telling the Arduino, hey, you know that pin we used, pin 13? I want you to set that up as an output because we're going to be sending power out of it to control our little LED. Okay, now we get to the real action, which happens inside the loop. The command digitalWrite is basically our light switch. When we say digitalWrite with high, we're telling pin 13 to send out 5 volts of power, which turns the LED on. And when we use digitalWrite with low, you guessed it, we're telling it to cut the power to 0 volts, turning the LED off. But here's the thing, if we just turned it on and off instantly, it would happen so fast our eyes wouldn't even see it. That's where this handy delay command comes in. It literally tells the Arduino to just pause, do nothing for a little bit. Here, delay 1,000 means wait for 1,000 milliseconds, which is just exactly 1 second. This little pause is what actually creates the blinking effect that we can see. Okay, we've built the hardware, we've written the software. Now it's time to put them both together and actually see the magic happen. This is the part where our digital instructions create a real physical result. So what's actually going to happen when you hit upload and send this code to the Arduino that's connected to our circuit? Let's see how our digital commands translate into real-world action. So the Arduino reads the code. First, it runs the setup part one time, setting pin 13 as an output. Then it dives into the loop. It sends power to pin 13 and the LED turns on. It waits for 1 second. Then it cuts the power and the LED turns off. It waits for another second. And then it goes right back to the top of the loop and does it all over again, forever. You've created a continuous loop of light completely controlled by your code. So there you have it, a blinking light. And I know it seems so simple, but what you've really done is take an idea, translate it into code, and use it to control something in the physical world. That is an incredibly powerful skill. So the final question isn't about how to do it anymore. It's about what you'll do with it. You just control light with code. What will you control next?